Good afternoon. Thanks for joining our talk today. Um, First of all, we'll just introduce ourselves. I'm Brent Rousel. I'm a member of the Starling X TSC.
And Greg Waynes, I'm a member of the Starling X project team.
Okay, so we'll start out by just giving an overview of Starling X, and then Greg will take over and talk about our distributed cloud implementation. First of all, what is Starling X? So Starling X is a full edge stack solution that is deployment ready, that focuses on high availability, high performance, security, and ease of use, both from a deployment perspective and day one and day two operations. We just recently finished our second release at the end of August, and we're moving towards our third release mid-December. Our website is there with more information. Okay, so a little bit about the architecture. So as I mentioned, it's a full edge stack solution. So we pull in many open source projects such as, whoops, such as Docker, Ceph, Calico, Armada from the Airship project. Then we layer on some Starling X services. And what these services provide are day zero deployment, day one and two management, and various high availability services. On top of that, we would have our Kubernetes components, which would include Helm, and on top of that, since we are a cloud native platform, we are deploying OpenStack as a set of containerized services, leveraging the OpenStack Helm and Armada projects. So a little bit about where we come from. So our first release, we basically provided a hardened platform based on OpenStack. In our 2.0 release, we basically turned it upside down, and now Kubernetes is the management framework, and OpenStack is now deployed as a containerized service, as I mentioned previously. The various deployment models that we support for the edge. So we can start as small as a single node. We have a two-node variant for high availability, and then we can scale up into multi-server configs, multiple racks. For the 1 and 2 server solution, the control plane overhead is as small as 2 cores, and our worker node would be 1 core overhead for the larger configs. We use Ceph as our persistent storage backend on all configs, and the smaller configs that would be hyper-converged. So Ceph would run with control and compute. So a little bit more about the Starling X services, which I touched on earlier. Oops. So first off, it provides the management of the physical infrastructure. So the deployment of the bare metal services, the updates to the host operating system, as well as fault management and host configuration. For the Kubernetes layer, then it would also manage the deployment and lifecycle of Kubernetes as well, and manage the OpenStack layer through Helm and Kubernetes. So at our website there's much more information on these various services. So our Kubernetes stack, I won't go through all these components, but I just want to touch on some of the capabilities. So currently we're deploying Docker Containerd as our container runtime. In our plans, we plan to also support CRI-O and Containerd standalone. Networking, we support Calico and Multus today, along with SRIOV for high performance networking, and looking for user feedback on other CNIs that they may like to see as part of Starling X. Device plugins support SRIOV and supported the CNI. We're also looking to integrate support for accelerators, GPU, FPGA, and the QAT. And runtime would be NVIDIA in support of GPU and the Kata containers, which is actively being worked on now. In our Kubernetes master, as mentioned previously, we support Armada and Helm. We also support a secure Docker registry for use by the infrastructure and cloud native applications. And I'll turn it over to Greg.
Right. Okay. So as Brent mentioned, basically our OpenStack solution is now containerized. So effectively, the OpenStack controller services are running in containers on the Kubernetes master nodes, and the OpenStack compute agents are basically running in containers on the Kubernetes worker nodes. And basically, the virtual machines that get launched and managed through OpenStack still get deployed directly on the hosts. So I'll talk about this a little more, but this definitely enables a lot of Kubernetes strengths with respect to managing, scaling, updating containerized services. So all of a sudden, those advantages become applicable to our OpenStack solution. With respect to how we install OpenStack, we use Helm, the Kubernetes Package Manager, and Armada from Airship. So with respect to Helm, we actually we leverage the OpenStack Helm project that provides Helm charts for all the different OpenStack services. And that was a big help in kind of our move to containerized OpenStack. We also actually contributed a lot back into the OpenStack Helm project with respect to, I think there was a few Helm charts that they didn't have that we needed that we contributed back in, as well as providing some enhancement to some of the services that they supported in their existing Helm charts. Airship Armada, we pulled in because Airship Armada provides orchestration for complex containerized applications that involve multiple Helm charts that have interdependencies between them, and that's exactly what OpenStack is, because basically, effectively, there's one or more Helm charts per OpenStack service. So, like, I don't know, I think there's about 15 or 16 different Helm charts in the Starling X OpenStack solution. So we leverage Armada for that. And then finally, Starling X actually provides application kind of package manager API that basically provides some wrapper kind of functions around managing an Armada manifest, as well as the Helm charts that it references. So some of the things it provides is when you do a Starling application upload of an Armada manifest and Helm chart, we'll do things like automatically apply Helm overrides to do things like apply the Helm charts appropriately to the deployment that you currently have in your Kubernetes layer. Like, for example, making sure the Nova scheduler Helm chart runs on the Kubernetes master nodes and not on a compute node. So there's some of the kind of Helm system overrides that we automatically provide to apply the containerized solution more effectively. and then we obviously provide support for the end user to specify his own Helm overrides as well in the exact same fashion as he would if he was editing the Helm charts himself. So just a look at the actual services that are currently integrated into Starling X. This is pretty much the list that we had in 1.0, except it's now containerized. I think there's a few additions. Barbican, I think, is an addition for secret management. And then we updated the telemetry solution because in 1.0 we had I think we were still using the deprecated Ceilometer backend, so we updated that with Panko and Noki. The other thing I should mention is that as part of the Armada manifest definition for our OpenStack solution, some of these services, I can't remember all of them off the top of my head, but some of these services are actually optional and by default disabled. Like, for example, I'm pretty sure the Ironic one is optional and by default disabled. So you'd have to do a Helm override in order to enable it before you applied the OpenStack solution. And then I think I talked about this before that, whoops, doing the same thing. Just at the bottom, just what I mentioned before was that OpenStack controller services are basically containerized, running on the master nodes, and OpenStack Compute Agent type functionality is containerized, running on the worker nodes. But then you guys probably know this. Then obviously the virtual machines that get launched from OpenStack are running directly on the host. So I mentioned, kind of stepping back with respect to the containerized OpenStack solution. There are a lot of benefits that we gain compared to, kind of a bare metal OpenStack solution. So the first one is that it's definitely easier to add OpenStack services in this containerized environment. Certainly back in 1.0, it was much more difficult. Because we were managing Starling or OpenStack directly on the host, we were using things like Puppet, and it was more of almost like a developer level interface in order to add Starling X or add OpenStack services to Starling X. But now it's basically a Helm chart. In theory, an end user could basically add a OpenStack service to the Starling X solution. I mean, that's not completely right. I mean, there are some Helm charts that actually have assumptions on what software is running on the host, but in a general context, it's just a Helm chart sort of thing to add an OpenStack service. The other thing is that it's much easier to do user configuration of OpenStack services now in Starling X with this containerized solution. Again, given that we were doing initial installation and configuration of the services through Puppet, it was much more difficult to provide end user access to that. But now it's basically a Helm chart override to, if there's some parameter from nova.conf that you wanted to tweak, that's probably a parameter in the Nova Helm chart. So it's a Helm chart override to tweak that. It's much easier to scale the control plane for OpenStack now. I mean, Kubernetes, you guys probably know, Kubernetes has a lot of capabilities with respect to replica sets and deployment sets, for managing multiple instances of a service and balancing across those. So it's much easier to scale the OpenStack control plane now. Definitely have improved HA solution just because the deployment and replica sets in Kubernetes, and for the Helm charts that were available for OpenStack, I think almost all of them are doing active-active HA, where we weren't providing. We had some in our 1.0 implementation. We had some that were active-active. We had some that were active standby. So certainly this is an improvement in 2.0. And then finally, the strength of Kubernetes in being able to update containers, the images and configurations of containers is going to make Starling software updates and full software upgrades of OpenStack much simpler. Okay, so now basically do distributed cloud type stuff. So just as a review, because Starling X's distributed cloud is available in 1.0 as well. So just as a review of kind of some of the key high-level objectives that we at Starling X had with respect to distributed cloud solution. First one is centralized management. So we wanted to provide centralized management over a set of geographically dispersed edge clouds. So and where the numbers of those edge clouds is in I was going to say hundreds, but more realistically, it's in the thousands of edge clouds that some of these end user use cases are looking at. So you definitely need centralized management in order to support that. Zero-touch provisioning. So given that you're going to have thousands of edge clouds, you're going to be doing provisioning and installation of edge clouds more often. So you need to make that process, as few manual steps as possible in order to, reduce errors and in order to make it more repeatable, because a lot of your edge clouds are going to be somewhat cookie cutter in kind of a common configuration. Single pane of glass. So we wanted to make the day two operations of managing the distributed cloud easier and simpler to use. So these are day two type operations, such as maybe incremental configuration of edge clouds, or kind of fault monitoring of edge clouds, or applying software updates to the edge clouds. All those type of things across multiple edge clouds we wanted to make, ideally through single pane of glass and kind of from a centralized, organized, orchestrated spot. Certainly high scalability is a key factor, and really in two dimensions. I already mentioned, we need to be able to support, thousands of edge subclouds, but we also need to support a range and size of the individual edge clouds. So there's going to be edge clouds that, just require a single server, but there's going to be edge clouds that require much more compute power, and edge clouds as large as a full cloud with hundreds of nodes. And finally, high availability. So as I mentioned, these edge clouds are going to be geographically dispersed. So not all these geographically dispersed locations are going to have reliable connectivity, which means that having edge cloud autonomy when the edge cloud gets isolated from the central cloud is a must in order for for some use cases where the edge clouds are providing critical services. Okay, so actually Starling X they've participated in the OpenStack Foundation's Edge Computing Group really since its inception. We've participated in use case discussions and their weekly meetings, and the definition of their reference architecture. So the Edge Computing Group currently has an MVP edge architecture. It actually has two variants of that reference architecture. There's a centralized control plane variant, and there's a distributed control plane variant. And Starling X actually represents an implementation of the Edge Computing Group's distributed control plane deployment scenario within its reference architecture, and that distributed control plane is basically defined as edge clouds having a full control plane at the edge, and really that's driven by the requirement, the main requirement of having edge cloud autonomy when isolated from the central stack. And besides providing that edge cloud autonomy, there's other advantages to having full control plane at the edge. For example, you get low latency response to other control plane services like auto scaling or reacting to recovery type requirements. Now the gotcha of distributed control plane is it absolutely requires, for usability and maintainability reasons, it absolutely requires that you have orchestration services at a centralized spot in order to manage all of these thousands of full control planes. So what's changed in distributed cloud in the recent work with Starling X is that distributed cloud, just like the core Starling X capability, has embraced the move to open infrastructure. Basically now, these Starling X edge clouds can now basically be, Kubernetes only type edge clouds, or they can be, edge clouds with a OpenStack solution, or even a mix of, or a larger edge cloud with even a mix of both an OpenStack cloud as well as resources for supporting non-OpenStack containerized workloads. So basically, distributed clouds had to be enhanced in order to support the fact that we could have a hybrid mix of edge clouds. And we really have enhanced it in order to be kind of hybrid aware and support all the existing orchestration services at the central cloud that we basically supported in 1.0. We've brought it forward in this kind of hybrid scenario. We've added a few things. So obviously we continue to support ease of deployment with respect to the initial installation of the edge clouds. We continue to support kind of a configuration portal or a mechanism to for selected data to be configured once at the central site and synchronized across all the edge clouds. Actual centralized Docker registry is a new capability that we have within the distributed cloud environment. Like Brent was saying, in our new Starling X Kubernetes environment, every cloud, every edge cloud has basically a local Docker registry, including the cloud at the top has a central registry. So basically the edge clouds can basically leverage a centralized Docker registry in the central cloud for pulling down container images. Continue to support kind of single pane of glass, Horizon for a variety of management activities, do centralized fault aggregation, and continue to support software update orchestration. So I've got a few slides on these individual items. Some have been enhanced, like I said, to support the hybrid environment. Some are things that we've just brought forward. So as far as single pane of glass, Horizon for fault monitoring, centralized fault aggregation. What I'm showing here, actually, I should mention the screenshots. Whoops, let me go back here. I should mention the screenshots that I have here are actually of a Starling X distributed cloud deployment on Packet.com. Packet.com is a bare metal cloud provider that has like dozens of different locations across the world. So you can actually deploy, a real geographically distributed cloud in their environment. And they basically donated some resources to the Starling X team and to the Edge Computing Group in order to do some, deployments and testing of deployments. So we're looking at that. Screenshots from that deployment. So what we're looking at here is the Horizon page at the central cloud, and we're looking specifically at a Horizon page for distributed cloud that shows a list of the subclouds. I don't know if you can see this, if you squint maybe. I have a Dallas subcloud and I've got a New Jersey subcloud, and you can see the subcloud list basically has a list of high-level states and statuses of the subcloud. Like availability status is just whether I have basic connectivity to the subcloud. Alarm status just indicates, a high-level view of am I seeing any alarms from the subcloud. Sync status again is high-level status with respect to synchronization of configuration data or software update synchronization. And then if I click on the arrow here, I can kind of explode and provide a little more detailed information on what's available at the central cloud with respect to subcloud status. You can see that, I've got detailed alarm counts for the for the subcloud, as well as detailed information on synchronization status and IP information, that sort of thing. And then there is a button here to get detailed alarm and event information. That information's on the subcloud, so basically kind of a single click, and now I'm on a Horizon page for the subcloud. You can kind of see up here in the project and region menu that I'm on the New Jersey subcloud now. And basically I'm looking at the Starling X fault management Horizon page, and I can see the details of the alarm that's actually active there. So single pane of glass, single tab on my browser, I can see top-level centralized view of all my subclouds, and I can drill down to diagnose a particular alarm. So same sort of thing for just generalized, management of OpenStack resources in the single pane of glass as well. Again, I'm showing the Horizon page on the central cloud. In the distributed cloud subclouds, I can go up to the project and region menu and select the Dallas subcloud, and now I'm sitting on now I'm on a Horizon page at the subcloud, and basically I can navigate anywhere in here to configure volumes or configure instances, and I just show here going to the admin compute instances page to see what instances I have running there. And on this packet.com thing, I don't know if he's here, I got David Patterson to deploy Squid, the open source Squid web caching application as kind of an example of a typical application that you deploy at the edge. And so he's got that deployed on our Dallas subcloud to provide web caching for this actual client it's providing the web caching for. But anyways, again, single pane of glass, single tab on my browser to do this. So as far as our data synchronization, I mentioned that we had a configuration portal to synchronize configuration data across the edge clouds, and basically there's the data that we're synchronizing. Some of the data is associated with the Starling X Kubernetes layer. Some of the data is associated with the OpenStack layer. For example, we have Starling X. We got some system data with respect to like DNS servers and NTP servers that the Starling X layer is using, and we have an instance of Keystone in the platform layer there, providing authentication for Starling X and some of the Kubernetes components. And all that data gets synchronized to all the edge clouds because the Kubernetes Starling X layer is on all the edge clouds. But for the OpenStack layer, we there's an instance of Keystone containerized in that solution, providing authentication for all the OpenStack services, and that's synchronized as well, but only synchronized to edge clouds running the containerized OpenStack. So just keep an eye on time. So software orchestration. So this hasn't really changed since 1.0. We continue to support it in 2.0. Basically, Starling X itself had a software orchestration tool that supported being able to, through a single command, being able to apply software updates to all the nodes in a particular Starling X cloud. And basically, in distributed cloud, that orchestration tool was enhanced to support basically iterating through all the edge clouds and then recursively through all the nodes within the edge cloud to apply that software update. And this is like an absolute must for any decent size, even a single node or a single cluster with a lot of nodes. Applying software updates is a lot of time to do manually and error prone to do it manually. So this is a big feature within distributed cloud. And then finally, zero-touch provisioning for deployment of edge clouds, and actually I am showing kind of a bit of a future view of some of the capabilities here. So what I've got here on the slide is a view of, what are the steps that I have to do at the remote site? What are the steps that I have to do, that I can do remotely from a centralized site? And you can see that we've reduced the number of steps. Basically, at the remote site, you can't get away from the fact that you have to physically go there, physically install the server, cable it to the top of rack switch, and cable it to, the BMC interfaces on the servers, so you can remotely manage the power for the servers. Remotely, basically 3 steps to deploy a cloud now. So the first step is all about installing the ISO, or installing the software on the initial server of the edge cloud. And I should just do a side note, if you've never installed StarlingX before, the idea is that you install the initial server with software. You install the software and bootstrap the software on your initial server, which will become controller 0, and then that server provides the boot server and installation and configuration services for the rest of the nodes in the cloud. So that's what this step 1 is doing, basically, is step 1 is basically power on the server, and then the future work that we're working on over the course of StarlingX 3.0 and 4.0 is to basically be able to remotely do an install of the ISO using Redfish Virtual Media. So step 1 basically gets me to my first initial server of the edge cloud to be run, to have the software load installed. Step 2 is basically a single command to do basically a subcloud add that adds the subcloud context into the central cloud's database, and then actually runs an Ansible playbook to actually bootstrap the services on that initial server, so that I've got StarlingX running, and I've got even my initial Kubernetes cloud up and running at the end of my bootstrap, and then it also can call an arbitrary deployment playbook where I can have scripts for actually doing subsequent configuration and deployment commands. And then step 3 is just the final step at the central cloud, where you indicate that, okay, this subcloud, now that I have connectivity and I can see, I'm going to manage the subcloud, which really just means, I'm going to start doing fault monitoring, I'm going to start doing synchronization of shared data and that sort of thing. Okay, so just a summary of kind of what we talked about in this talk. Brent talked about basically the StarlingX 2.0 evolution to the open infrastructure, having Kubernetes at the bottom layer and containerized OpenStack. I talked a bit about distributed cloud, how it's evolved into the open infrastructure with respect to supporting a mix of edge clouds, being Kubernetes and OpenStack. And then independent of that, I talked a bit about the zero-touch provisioning improvements that we've done around making it Ansible playbook based. So there's a lot of kind of future things that we're thinking about, or planning for StarlingX distributed cloud in the future. Talked about one is that we're doing the install software using the Redfish Virtual Media. Some other items that we've talked about: securing inter-region communications. Actually, integration of Kubernetes Federation version 2 is something we really want to look at, because basically StarlingX distributed cloud is a collection of multiple Kubernetes clusters, and that's exactly what Kubernetes Federation does, is provides federated services over multiple Kubernetes clusters. So it's definitely something that we want to explore, being able to automatically set up on a distributed cloud environment. There's some edge device management that's being talked about with respect to smaller, not fully managed devices, and then we've talked about geo-redundancy at the central cloud as a requirement. And then maybe last slide before I open up to questions, just wanted to throw up the StarlingX community slide. There's a bunch of links here to where our code is, some of our docs, we use Launchpad for tracking bugs, Storyboard for stories, and write specs for all the major stories that we're tracking in Storyboard. There's a mailing list. We've got a wiki that has a list of all our meetings. We've got way too many meetings, but it's a big project. And basically, if any of this, this stuff on distributed cloud interests you, or just the stuff on, the core Starling X stuff interests you, anyone's welcome to attend the Starling X PTG meetings tomorrow and Thursday. We were got a lot of work to do and looking for contributors. All right, any questions? Yep. Someone over there. Yep.
I just got two questions. So the first one is a very hot topic in our. So there's when integrating OpenStack with Kubernetes, there's actually or vice versa. There's actually the OpenStack on Kubernetes or Kubernetes on OpenStack. So because as in your presentation, you guys are doing OpenStack on Kubernetes, and just out of curiosity, what's the thought process behind that?
Well, the thought process on that is basically, twofold. I mean, one, we wanted to be able to support kind of a very small deployments that are basically Kubernetes only, and then secondly, having OpenStack on top of Kubernetes. Like I mentioned, there's a lot of advantages to having OpenStack containerized. Like I mentioned, right, like ease of adding services, ease of configuration. So that was a key thinking as well. I mean, we still, I didn't show Magnum up there, but that's still a service that you could, in theory, add to Starling X in order to, if maybe for multi-tenancy reasons or something like that, you wanted to add to support basically Kubernetes on OpenStack on Kubernetes.
Right. Okay. Cool. Another question is because based on your presentation, I saw, for example, in your distributed cloud architecture, there's still going to be a full set of OpenStack services running on the subcloud. Is that right?
Well, basically, for every edge cloud, you can decide whether it's Kubernetes only or whether you want to incrementally deploy OpenStack. And it really depends on the workloads that you want to run, whether they're containerized ones or virtual VM-based workloads. But then, like I mentioned, is that the list of OpenStack services that I had, not all of them are deployed by default. There was some of them, I can't remember the exact list. I know Ironic, maybe telemetry I think is optional as well. So we do have the ability to pare down the size of the OpenStack deployment.
Yeah, because as a telecom user, we are really curious about, can we do, for example, a lightweight OpenStack deployment on the on the edge nodes? For example, not only just reducing the components of OpenStack, but also from the mechanism level. For example, reducing the numbers of the RPC calls, etc.
Yeah, I can see why that would be a use case that somebody would be looking at, and I mean, I think we'd be open to exploring that in Starling X. So.
Okay, thank you.
Yeah. Any other questions? Yep.
So Starling X looks to me it's a quite a big picture. You are trying to manage the bare metal, manage the OpenStack, manage the Kubernetes. So it looks quite a complicated software or platform. So how do you manage all the features and qualities of the software, and how?
Yeah, it's a good question. It is a big project. We have, I don't know how many sub-teams we have. We have, I don't know, about 8 or...
Yeah, probably about 12.
Yeah, so about 12 sub-teams that are working on different areas of Starling X. And we do have, and then also with respect to your comment about quality, you're right, is that that is something we're working on improving with respect to our open test team, basically for validating the services of Starling X on a regular basis.
Yeah, I guess one thing we do in Starling X is we do perform end-to-end system integration testing versus just unit and functional testing.
Any other questions?
那个 you mentioned that 那个 install software via BMC's Redfish virtual media function. Does it mean installing in operating system or in application?
Yeah, so our plan is to integrate the Redfish virtual media into our host management subsystem. So we have one of the projects within Starling X is responsible for managing the life cycle of the host. So Redfish virtual media would be support would be integrated into that component.
Okay. Does Redfish have monitoring installing progress? When you install OS.
Yeah, so we'll use Redfish to do the initial installation of the first node in a cloud. So that would include the entire software stack, including the OS. Yes.
Okay, thank you.
I don't know if we're out of time or. Yeah, I think we're out of time. All right, thanks very much for attending.
Thank you.